Hello viewers, could you make out the process going on your TV screen just now? Well, the answer could be both yes and no. However, this program will benefit everyone. The process you are viewing is super finishing, and that is the topic of our program.
What is super finishing? Super finishing is the process used for improvement of machined surfaces to make them more wear resistant. Here we have a surface with an uneven load distribution as the surface is not super finished. Super finishing removes the burnt out layers of the surface and corrects the inequalities in geometry. This gives high finish and leads to even distribution of load. How is super finishing done? Super finishing can be accomplished on a standard center lathe with the help of a super finishing attachment. Let us be familiar with its main parts and operating elements. Support bar. It is clamped into the tool holder of the lathe with the help of the fixing screws as seen here. The tool holder can be turned to the right position of the workpiece. Now the super finishing attachment is fixed to the round shaft. Stone guide. The stone guide consists of an air cylinder with a piston to which the stone holder is fastened. It is operated by the control valve. The stone guide is connected with the attachment by means of a dovetail guide allowing longitudinal adjustment. Stone holder. Because of their spherical head part, The stone holders are fastened in the piston rod of the stone guide. The universal mobility allows the stone to be set precisely to the workpiece. Pressure reducing valve. The stone contact pressure is adjusted by this valve. It is increased by turning the valve to the right and reduced by turning it to the left. The adjusted pressure can be read on the dial. Stroke regulation valve. This is the stroke regulation valve. The stroke is lengthened by turning the valve to the left and reduced by turning it to the right. Up to its complete stop. Stroke value indicator. The stone guide is provided with a scale showing two crossing straight lines. The stroke value in mm can be read off from the apparent intersection of the straight line. Putting the attachment into service. The workpiece is clamped into the jaws of the chuck. The attachment is moved towards the workpiece and positioned in a way that the axis of the stone guide by sighting is through the middle of the workpiece. Connection of air pipe. This is how the air pipe connects the attachment to the main air compressor for air delivery. For proper regulation, air pressure should be between 0.5 kilogram per centimeter square and 4 kilogram per centimeter square. Place a collecting container at the slide rest directly under the workpiece. Fixing of stone. Set the stone into the stone holder and fasten by means of the clamping screw. whilst lathe and attachment are not yet running, a slight pressure has to be given so that the stone approaches the workpiece. Dressing of stone. Dressing of the stone is done by placing a strip of coarse-grained emery cloth under the workpiece and pushing the stone held in the stone guide. The oscillating attachment will move the stone against the abrasive cloth. The abrasive cloth has to be taken to and fro until its desired profile is formed on the stone. Now you can start the super finishing. Procedure for super finishing. We have got a mathematical explanation and a physical explanation for this. This is a cylindrical rod as seen by the naked eye. However, on micro-study, we see the irregularities on the metal surface. The figure shown will help us in understanding the basic governing equation for super finishing. The equation is tangent beta equals pi into d into n over a into f, where A is the amplitude of stone vibrations in millimeter, maximum amplitude is 6 millimeter. F is the number of strokes per minute, about 500 cycles per minute. D is the diameter of workpiece in mm. N is the RPM of workpiece. V omega is the velocity of workpiece in mpm, about 20 meters per minute. P is the contact pressure between stone and workpiece, about 0.5 kilogram per centimeter square to 4 kilogram per centimeter square. It is evident that as the angle beta increases, the finishing improves as the super finishing process makes the lines disappear. The early stages of the operation consist of the abrasion of the peaks and ridges. As of such, contact is only at the isolated points with increased pressure on these points. As the work approaches nearer to a true cylinder, the area of contact increases. Thus, the pressure on unit area is reduced. The load on each individual grain becomes very small and abrasion practically ceases. For the sake of understanding and clarity, let us compare the grinding process with the super finishing process. There is high surface speed at about 2000 meters per minute in the grinding process, whilst in the super finishing process there is less surface speed at about 100 meters per minute. Contact pressure between grinding wheel and workpiece is usually very large in the grinding process, whereas contact pressure is usually very small, about 1 kilogram per centimeter square, in the super finishing process. Contact area is very small in the grinding process, at the maximum only line contact. Contact area is very large in the super finishing process. The entire surface of the abrasive comes in contact with the workpiece. The grinding process is less accurate due to the possible work deflection and distortion. The super finishing process, on the other hand, is highly accurate as no deflection and distortion of workpiece occurs. Surface finish is less in the grinding process, whilst in the super finishing process we obtain high surface finish. Due to high temperature produced during the grinding process, burnt out layers will be present near the surface produced, while in the super finishing process less temperature is produced, hence no burnt out layers are left as in the grinding. In the grinding process, running in period is required for ground surface before full load can be applied. No running in period is required for super finishing.